All right, so let's do our own here, right? So we're going to take this thing and we're going to move it to here, right? It's going to go from here, which is in the dead center, to here, which is going to be 0.06 meters from here and what, 0.18 from here. Okay, and so we're going to do the four-step process here, right? Find the initial voltage, right? Step one. Step two, find the final voltage, right? Step three, find the change in voltage, right? Which is the final minus the initial, right? Step four, work is change in voltage times charge, okay? So let's solve away. We need so much space here. Helps to kind of divide up here, especially since I'm a spaz. Okay, so my initial voltage is going to simply be that. And by the way, when I do this, I don't even put that charge there, because of course the voltage right at the center of that charge, or right on that charge, would be infinity if it was a point charge, really. Okay, so the initial voltage is the voltage right here where it is, right? So that's 8.99 E9 times positive 3.2 E minus 6 over 0.12, right? Plus, and then we got to do this guy here, so it's going to be 8.99 E9 times negative 4.1 E minus 6 over 0.12. Okay, I'm going to store that somewhere. All right. Okay, here we go. All right, 3.2, 3.2, that's my family, my family's home. Okay, 0.12, 0.12, okay, plus 8.99 E9 times negative 4.1, so negative 4.1 times 10 to the minus 6th, right, divided by 0.12, is that right? Yeah. Okay, I'm going to store this in A just for the kicks here, and I get negative the actual potential where it is, and of course it should be negative, right, because this is a bigger charge and they're equidistant, right? So it's negative 67,425 volts, and that's our initial voltage, right? Our final voltage, okay, is 8.99 E9 times 3.2 minus 6, and that's positive, right? Divided by, and then this distance now we've moved it over, so it's 0.06, right? Plus 8.99 E9. It's going to be positive work because this guy doesn't want to get moved that way, right? Okay, negative 4.1 E minus 6. And then this guy will be divided by, we moved it over, so it's 0.18 now. Okay, so let's do that. Now I'm not just going second entry and editing the distances. I'm typing the whole thing over again. No, as a matter of fact, I'm just editing the distances. Okay, so 8, and I'm storing that in alpha B, just for fun. Okay, wow, that's a bigger number. So this actually ends up being, I'm somewhat surprised at that. Let me make sure I did that right. The other one was negative. This one's big positive number. Wow, 0.06, 8.99. Yeah, I got it right. Okay, so this is positive 274,694.4 bar volts. Okay, that's a 9, and this guy's a 4. Okay, so our final minus our initial, right? Our final minus our initial looks like positive 274,694.4 bar minus a negative 67. This is where it gets all confusing, right? We're actually subtracting a negative, right? Okay, so I'm going to go minus alpha A, just for fun. And of course I get that the change in voltage is tremendous. It's 342,119.4 bar. All right, 4 bar. All right. So that is our change in voltages, and we should expect that, right? We moved it from here to here, that we're moving it to a place where it's higher positive potential, right? And then our work is simply change in voltage for the moved charge, and now we use this number. Haven't used it yet, now we use it, right? So work is change in voltage, so plus 342, right? That's joules per coulomb, right, of work, times, we are moving 13 microcoulombs, so 13e minus 6. And if that were negative, you put a negative in there, and there you go. Okay, and that's coulombs, right? So this times 13e minus 6 is 4.447557 bar, it looks like. Okay, so we have only 2 sig figs. Sadly, we have to round to here, and so all of that stuff is lost. It's positive work, okay? So be careful of your signs. Make sure you're saying final minus initial, right? And then be careful of the sign of the moved charge. The moved charge is not used in any of the voltage calculations. Okay, so you figure out the situation if that charge weren't there, and then you move the charge. Yay.